today's project is going to be adding a defrost board to my old Amana PTAC. So basically, the original circuit board on it got to where it wouldn't even, like, it was saying it was like 75 degrees when it was actually 60, or was it the other way around? I think, no, it had been saying it was like 60 when it was actually 75, sorry. So anyway, so I eventually got rid of that original circuit board, just rigged it up with some contactors and a thermostat on the wall of my shop so I could just turn it on and off when I wanted to. But now, of course, it ices up because it doesn't have a defrost mechanism or anything. Originally, it would just shut off the reverse cycle heat and turn on a strip heat or electric heat when it got cold enough that it thought it might ice up. But of course, I'd rather have it actually defrosting. So I'm going to see what I can do today. Got a bunch of these White Rogers universal heat pump defrost boards from Emerson. So I got them for like 50 bucks each. I bought them off a guy on eBay, new old stock. Of course, I bought 4 because I never know what I'll use one for next. So here's the unit. So I've got it hooked up basically right now to this thermostat. I've still got the original circuit board on it for controlling the fan and reversing valve. It's basically just serving as a couple of relays because why not? And the actual compressor and strip heat are controlled by a couple of contactors in there. I'll pull it all apart and show you in a moment. I have it hooked up so that for auxiliary heat or emergency heat, I have a jumper between auxiliary and emergency on the thermostat, so either one will kick in the strip heaters. Right now it's running, it's a couple degrees behind because I turned it up to get as warm as possible in here. It's cold outside. I want to be as comfortable as possible while I'm doing this job, so I'm going to have to cut it off, of course. Anyway, I've got it so whenever it drops below like 1 or 2 degrees, it'll kick in the auxiliary heat strips to help keep it warmer. You shouldn't have to do that as much though now that I've got a defrost board. So let's see what we're gonna do here. I'm just gonna cut it off here. It's warm in here right now, but it won't stay that way. Probably need to turn on all my little heater back there. So, got it cut off. I'm just gonna unplug it from there. Why unplug it? Let's turn off the breaker. So yeah, I'm gonna pull that apart and see what we can do. Here we go. So as you can see, all the heater wiring and compressor wiring is just disconnected from here. So this is just for controlling the fan and reversing valve. I might rip that thing completely off. I'm not quite sure yet. So we have, like, how is I even getting 24 volts from there? I guess from those terminals, okay. Anyway, so as you can see, I've got just one of these relays that's rated for like 4 or 5 amps, I'm not sure. This one right there, I got both of these for free. That's for the compressor, and down there, yes, I know you weren't supposed to use a compressor contactor for strip heat, but I mean, why not? It works. And has worked for a year. So we've got some room in here for a defrost board, but not a whole lot, so I'm not sure. I might put it on here. I'm going to go and take the defrost board out of the packaging and see what it looks like. Okay, so not only can we make this thing defrost, we can give it a demand defrost, because this thing comes with everything you need. A couple of the, what are they, thermistors? Yeah, thermistors. Couple of those, unlimited wiring and zip ties and screws. That's nice. All kinds of wires, and yeah, a very compact little defrost board. Got a bunch of relays on it, but I'm not sure what all its functions are, or how exactly. I'm gonna have to look this up. I'm gonna look at the instructions, and then I'll make some more video and tell you what my plans are. So, I mounted the defrost board right there because this area is so crowded and I'm would rather keep this board just for because it has the reversing valve relay and fan relay on it. I'd just rather keep it that way. So anyway, I put the defrost board right there. Now I have to make sense of this tangle of wires. So I'm just gonna run a wire from the let me think. The one from the reversing valve, and they all just connect right to here. And then the outdoor fan wire, I'm just going to disconnect from the capacitor there and wire it up to the relay on here just so that the fan can stop for the defrost. Basically, I'm just going to do all the wiring, and then I'll show you how I rigged it up afterwards, because it's going to be kind of complicated. So the fan was connected right there. This wire, this purple wire is for the compressor. And let's see, right underneath it we have a yellow wire. It was a black for the fan that was connected to here to the compressor contactor. So anyway, I ran this yellow wire here to this fan relay, and then I have the fan wire plugged into that. Fan wire was plugged in right there. So now we control the fan for defrost. Anyway, so I've been disconnecting all the old thermistors because we don't need them. Definitely don't need them hooked up to here now. Already didn't need them hooked up to there. But the outdoor coil temperature sensor I've got pushed through the hole. I'm going to go and pull it out completely, and then put in that new outdoor coil temperature sensor, and of course the outdoor air temperature sensor. So my brother helped me fish the wires through that hole back there. Wasn't too difficult. I'll show you what we did in a minute. I'm going to swap these out though. So this thing already had a coil temperature sensor. Get rid of that. We got a brand new one here. Let me just get the wire behind these coils, make it look a little better. I got it tangled up, but it won't do any harm. Okay, let's clip this on like this. That should give me a pretty accurate reading, I guess. Hopefully. And then we've got our outdoor air temperature sensor. I don't want that near the coil because that might give me an inaccurate reading. So what I'm gonna do is drill it through. I'm gonna drill a hole in this. This is a wooden sleeve. The reason this thing has a wooden sleeve is I got this PTAC for free a few years ago. Didn't have a sleeve, and I was like, all I had wrong with it at that time, apart from the sketchy control panel, all I had wrong with it was a bad overload protector on the compressor. That should give me, hopefully, a fairly accurate reading. And, yeah. So we'll go connect it up inside now. Okay, so that's good enough. It's not great. There we go, that's better. Sitting on there better now. So to get the wires from the back of the PTAC through that hole, I use this grabber thing. When you squeeze that, these jaws open. Alright, phew. I got all the wiring done. So the low pressure and high pressure controls are not connected, as you can see, because, well, like I said, they're not going to be used. I still have one reversing valve wire and one contactor wire. That I think those are just commons. I don't think I'll need those. Anyway, so I've got the contactor and everything wired to the defrost board. So I've got the indoor fan hooked directly to this circuit board just to control the fan. I have this circuit board set up, by the way, as for if the PTAC was going to be controlled by a wall thermostat. So this thing thinks it's being controlled by a wall thermostat. Anyway, so the the reversing valve wire from the defrost board is connected right to here to signal that relay and kick in the reversing valve. And pretty much all the other wires, the auxiliary heat, Y, and reversing wire, compressor wire and reversing wire, all that are wired directly into the defrost board. So that's pretty much all wired up. Now we just have to program it. Yeah, we'll see how that goes. And it should be good to go after that. Let's kick it in. On. And make sure the thermostat's off, yes. We've got our smiley face going. We need to reposition that so it stands in the proper position instead of being sideways. And this thing is griping about that all the wires are disconnected from it. And by the way, that display's messed up too. It's griping about that we disconnected all the sensors from it. But as long as it'll still signal the fan, that's all I need. Let's see if it does. I'm not sure with all the sensors disconnected if this thing will even signal anything or not. But at any rate, let me go and program this defrost board. Okay, so it says press the option button for 1 second and and I click select until they're in the proper position. Oh, it's not doing that. High. No, it should rotate. It's not rotating it. That's upside down. There we go. You can set it for OEM, and I'm just gonna program it. I'm just gonna go through everything and program it for how I want it. Alright, so I got everything set up. So I left most everything in default, number 8 default setting. Like I left the temperature that enables the defrost, the ending defrost temperature, all that, but I had to reverse the setting for energizing the reversing valve. And let's see, what else did I have to? I changed the reversing valve shift delay to 0 because I don't mind the big whoosh when it reverses. I actually kind of like it. Let's see, what else did I added? Of course, deactivate the low and high pressure switches. But that's about it. So I figured out the reason it wouldn't work was just because the indoor air temperature sensor was disconnected. So I just soldered it back to there just like that. Should be good enough. And now the fan cycles as it should. Hopefully the reversing valve does too. We'll run a running at heat now, and can try the defrost cycle too, hopefully. It has a quick test mode. We'll try that. At least the defrost whatchamacallit, the reversing valve is functioning now. That's good. So it's heating now. Let's see, so I'm gonna do the defrost test. Let's see. So it says we will push both of these buttons for 1 second. Okay, it's in test. Cut the compressor off and reversed. I don't know why it insists on cutting the compressor off. No, I'm sorry, the compressor is still running. The fan stopped, and I'm not used to that, I'm sorry. The compressor itself is quiet, and you have the heat strips kicked in. That's good. So, yeah, it's cooling, but the air still feels pretty warm, thankfully, because the heat strips are engaged. And of course I could also, if this thing didn't have heat strips, switch back in heat. There we go. If this thing didn't have heat strips, I could also just have it stop the indoor fan as well as the outdoor, but don't need that here. Because I'd rather have it just keep going so it can keep up. Anyway, so we're still gonna see. It wouldn't kick in emergency heat when I tried that, but let's just wait and see if it kicks in auxiliary heat, because that thermostat is it's a couple degrees behind, so it should kick in emergency heat. We'll see how that goes. So the thermostat did kick in the heat, the auxiliary heat. Let's test cooling just to make sure it will run in cool mode. Yeah, let's see, 59 degrees. So it's got a 3-minute compressor delay on here. So now it's kicked in cool mode. That air is nice and cold. Not that I want to be cooling my shop right now, but I just want to verify that worked. So I'm going to cut off the power now and close everything up. Seems to be functioning as it should. I could hook another wire to the thermostat and hook it to that thing for a emergency heat, but it's kind of pointless. I don't really need it, so let's turn off the thermostat and let that thing cut off, and then shut off the power. Okay, I'm gonna wait for that thing to turn off. It's now running and heating. Seems like everything is good. We'll have to see if we can catch a defrost with it before I post this video. Only problem is it'll probably mostly be defrosting at night when I'm inside the house. But we shall see. It's pretty warm, pretty nice day today, but it might defrost this evening. We shall see. Auxiliary heat kicked in, that's good. Them both working together, it ought to really pump out some heat. This thing's like a 9,000 BTU, 12,000 BTUs of strip heat. In the summer, it keeps up pretty well on milder winter days, just with the heat pump, with the auxiliary heat. With just the auxiliary heat, it works on pretty cold days, so it should do really well now. In the summer, I have to run this other window unit as well to keep it cool in here, because you see the shop's not insulated. And obviously that window unit should not be down there, it should be like right there, but that was my dad and my logic 6 years ago put it down there. I've got to hook it up to run off the second stage when the thermostat calls for a second stage in the summer, but it works. So we'll see how this goes. It should work pretty good. Seems to be working good right now. Working pretty well. It's putting out some hot air in there with the auxiliary heat and the heat pump going, but even the heat pump is working good. Frosting up a little, so we might can catch a defrost this evening. I don't know. It's working good so far though, for sure. So seems to be defrosting good. It's defrosting right now. I just happened to come out. I wanted to see how it was doing. It's like it had a lot of ice on it. I've watched it do 2 defrosts now. I just hope it isn't defrosting every 5 minutes, but as long as it's defrosting like every 40, that's fine. Plenty of water dribbling out. Looks like it was quite icy, so needed doing. Seems to be working pretty good, but it seems to have sufficient airflow. Doesn't feel like it's too iced. It's hard to tell, but I mean, it seems to be working. The fact that it's still at 66 degrees in here and it's only signaling the heat, turning on the electric heat while defrosting at 65. It's pretty good. Let's see how it holds up, but it's doing really good so far and heating very well. It's good. It's now the next morning. didn't get that cold last night, but went down into the 30s. And it is pretty badly iced at the bottom. So I wonder if I ought to move that temperature sensor a bit further down on the coil. Possibly. But overall, it's still got airflow, so that's not too bad. Another update on trying to make this PTAC into a real heat pump. So I found that the problem I was having was that it was getting so much ice collected down there from it defrosting repeatedly. It was getting stuck on the slinger ring, locking up the fan. The fan never burnt out, thankfully. This locked rotor amps is like 0.48 amps. So I guess technically a motor like this from these little split capacitors, I guess they can't even really technically cut and burn out from a locked rotor. But anyway, I don't want to cut the slinger ring off. So what I'm trying instead, I bought one of these pipe heating cables, and I have it ran along here, and then ran along there on both sides of the slinger ring. You can see some of it in there. Probably need to get it pushed down into there a little more, but I gotta wait for all the ice that's in there to melt first. Just got a thermostat against this piece here, which I don't know, it probably gets cold enough for it to make it turn on. Probably. It's not quite as cold as that, but it should be fine when it gets really cold. I might insulate that, I don't know. Waiting to see how it performs tonight. I'll put the wood piece back on top if it does work good, but I'm not quite sure how it's going to do yet. But we will see. I went down into the maybe like 20 last night, and anyway, I don't know if it's gonna always function this well, but it's not iced up at all right now. It looks like the heater has been working. It's drawing like 72 watts, and it stays like that. I'll just run the cord from the heater inside and wire it right up to the PTAC. Okay, so it has yet to ice up. I've just had the heater cable on an extension cord, and it's been drawing pretty steady, like 70 watts when it's been cold. Used over 2 kilowatts now. Expensive heater cable. Well, anyway, it's great if it keeps it from icing up. So I'm gonna go ahead and hardwire it. It's 120 volt, but I'm sure that I can wire it up here somehow. I'm just gonna cut the cord off and put the cord through that hole there. Then I'm gonna put the top back on here and then wire it up. So, got the cord in here, fished through the hole. I'm thinking that for neutral, I'll just go off the PTAC ground wire, and then for hot, I'd like the cable to only be energized when it's in heating mode. So that heating cable was a 6 feet and 30 watts cable. It's funny because it drew like 60 or 70, but it heated good. Heats good.